All right, so today I want to start by looking at the graph of tangent, and then I also have included a space where we can graph cosecant, cotangent, secant, but we're going to use the unit circle to actually help us do this, okay? So we're going to derive the graph of tangent of x here, all right? And I'm going to do this using a little table because using our quotient identity, I know that tangent equals what? Sine over cosine. All right, and we've already talked about this, that if you know your unit circle, you can get the tangents of different angles by simply dividing sine divided by cosine. Okay? So, we have sine of x, cosine of x, and then we're going to use that to find tangent of x for a number of different angles. Okay? So I'm going to start at 0, and then we'll do pi over 4, and then we'll do pi over 2, and then 3 pi over 4, and then pi, and then 5 pi over 4, and then 3 pi over 2, and then 7 pi over 4, and then 2 pi, okay? So we're just going to go around the room and practice our unit circle while we're at it here too. So let's start with Matthew. What is the sine of 0?
The sine of 0 is going to be 0.
It's 0, okay? Yeah. What's the cosine of 0, Rachel?
0. I don't know.
Well, get your unit circle. Remember, cosine is which coordinate?
X.
X. So at 0 radians,
1.
It's 1, okay? So if tangent sine divided by cosine, what's our tangent, Naya?
What?
What's our tangent of 0?
0.
It's 0. 0 divided by 1 would be 0. Okay? So now we have our first point on our tangent curve. Okay? All right, Davi, what's the sine of pi over 4?
Pi over 4?
Mm-hmm.
Radical 2 over 2.
Radical 2 over 2. And Jared, what's the cosine of pi over 4?
Radical 2 over 2.
Radical 2 over 2. Good. So, Hannah, what is the tangent of pi over 4 then?
Of what?
Pi over 4. Sine is root 2 over 2, and cosine is root 2 over 2.
5 pi.
No. Remember, tangent is sine divided by cosine.
Oh. I don't know. 1?
1.
Okay.
Yeah. Okay, so tangent's 1. So here I have, at pi over 4, I am at 1. Okay? All right, so let's see, Han. At pi over 2, what's the sine?
Pi over 2.
Mm-hmm.
I don't know what.
Look at your unit circle if you need to. At pi over 2, what's our sine?
90.
What?
90 degrees.
Well, that is what pi over 2 is in degrees. What's the sine of pi over 2?
It's 1.
It's 1, okay? Ling Shen, what's the cosine of pi over 2? 0. Good. So Alex, what's the tangent of pi over 2?
It's going to be 1 divided by 0.
That's exactly right. It's 1 divided by 0, so it's undefined. So guess what we have on our graph?
0.
Oh, space.
Not a hole, the other thing. Yeah, good, an asymptote. We have this asymptote at pi over 2. Okay?
Zero never be
There is no tangent of pi over 2. It's undefined.
Oh, because it's
Okay? Because cosine equals 0.
If from a rectangle, it's impossible to
Okay? Now, let's keep going. 3 pi over 4. Now we're in the second quadrant. Alright, so Harrison, what's the sine of 3 pi over 4? Good, radical 2 over 2. How about cosine of 3 pi over 4, Ryan?
Cosine of 3 pi over 4 would be
What?
negative radical 2.
Good, negative radical 2 over 2. We're in second quadrant, so cosine's negative. So, Susie, what's our tangent of 3 pi over 4?
Radical to, so is sine divided by cosine.
Yes?
1. Negative 1.
Negative 1, very good. Okay, so now we have another point here. Here's negative 1. So we have a point right here. Okay? Alright, so now we're at pi. Yudi, what's the sine of pi? 0, good. And Kaoru, what's the cosine of pi?
Minus 1.
Minus 1. So me, what's the tangent of pi?
0.
Don't use our calculator. 0. Okay, it's 0 divided by negative 1, right? Okay, so it's 0. Alright, so here's our point. Okay, let's see, now we're at 5 pi over 4. So Matthew, what's the sine of 5 pi over 4?
Sine of 5 pi over 4 will be negative 1 over 2.
Not negative 1 over 2.
That's the same thing.
Negative radical 2.
It still has the reference angle pi over 4, right?
Yeah, so pi over 4 would be negative square root 2 over 2.
There we go, good. Guys, we're dealing with the same reference angles on all these pi over 4s, so they're all going to either be pi over root 2 over 2 or negative root 2 over 2. You just got to figure out which one it is. How about cosine of 5 pi over 4? Rachel?
Same thing as the sine.
Good, same thing as the sine. Third quadrant, they're both negative. And that means tangent equals what? Naya?
Asymptote.
1.
No?
Wait, what?
1.
What's tangent?
1.
Look at our sine and cosine.
Oh, we're still on this one? 1.
It's 1. Okay? So here we have
Thought we went on.
that. Okay? Now we're at 3 pi over 2. So, Davi, what's the sine of 3 pi over 2?
It would be 3 pi over 2. Think about 3 pi over 2.
See your unit circle.
Minus 1.
Minus 1.
I was thinking over 3, adding 1.
Okay.
Minus 1 is 0.
Cosine?
Oh, 0.
0. So, what's tangent, Hannah?
0. Or like nothing, it's an asymptote.
There we go. It's undefined. Negative 1 over 0 would be an asymptote. So, we've got another asymptote here.
I thought we went on to this one. That's why.
There we go. Alright, so let's see. Han, we're at you now. 7 pi over 4. What's the sine?
7 pi over 4. It's, I don't know.
Look at your unit circle.
Yeah,
Find 7 pi over 4. Which quadrant or which coordinate is sine?
yeah. The fourth one.
Well, no, we are in the fourth quadrant. That's correct. So sine is negative. But you have the coordinates of your point. Which one of those is sine?
Radical 2 over 2.
It's a negative radical 2 over 2. Okay? Sine, remember, is always the y coordinate. Cosine is always the x coordinate. Alright? So, Lingshen, what's the cosine of 7 pi over 4? Not the same.
Oh, positive?
Good, it's positive, all right? Because we're in the fourth quadrant, so cosine's positive. So, Alex, what's our tangent? -1, all right? Are we seeing a pattern here yet, guys? Okay, I hope so. What's 2 pi? Same as 0 was, right? So it's 0, 1, 0. So we're back up here, okay? And if I kept going, I'd be back at 1. And then I would have an asymptote. This is a periodic function, so you repeat here. If I went to the left over here, I'd be down at -1. And then I would have an asymptote, okay, at -pi/2. Alright, so here's what this looks like. You guys know that as you approach an asymptote, it gets closer and closer and closer, but never touches. So we've got that. It's going to come down, kind of level off a little bit. So it almost looks like a cubic. Just repeated over and over again. The difference is it has that asymptote that binds it, as opposed to the cubic that keeps going forever in the x directions. All right, but it's the same kind of look. All right, so there's tangent, and it keeps going, of course, so repeating that pattern. What do you notice about the period on tangent? No, that's the domain. That's the range is infinite. But the period,
Every
1
unit
pi.
circle.
1 pi.
it's 1 pi. Every unit circle, what happens? Okay. Every full unit circle, we go through the period twice, right? So that means our period in this case is just pi. All right? Tangent is a little bit different in this sense, okay? Because sine and cosine both had periods of 2 pi. All right? So there's our tangent graph. We're not going to do a ton with that, but it's helpful to see it because, again, like we had before, you can actually see that all students take calculus, right? In the first quadrant here, tangent's positive. In the second, in the second quadrant, tangent's negative. Here in the third quadrant, tangent's back to positive. And then in the fourth quadrant, tangent's negative again. Okay, so you can see it here in the graph as well. Rachel?
Is the period pi because like sine and cosine are like 2 pi, so it's like half of it? Or no?
Well, I mean, it is half of what sine and cosine are. It's simply just the nature of the fact that sine and cosine are like that pi/2 off from each other. They're shifted over from each other. So when you're finding the ratios, those ratios end up repeating sooner or more often. Okay. Now, I've given you places where you can graph these other ones, okay? We're not going to go through all of these just for the sake of time, but one thing that you would see on these is that if you were to graph cotangent, it actually looks the same, except shifted over. Okay, the cotangent has an asymptote, let me get back to the pen, has an asymptote right on 0, and then on pi, and then at 2 pi, because that's where sine equals 0. Before we had asymptotes everywhere cosine equaled 0 when we were doing tangent, okay? But then we're going to have at pi/2, where there was an asymptote for tangent, we're actually going to have it hitting the x-axis at 0, and also at 3 pi/2. So you'll notice the look of this is the same, it's just been shifted over. Okay? And actually, if we look at the next slide here, you can see all of these side by side. Here's tangent, and whoops, I got my cotangent upside down when I graphed it there. So it's going down here, okay? But you see the asymptotes at 0, pi, and 2 pi, all right? Secant and cosecant, here's cosecant on the left, secant on the right. You can see there we have asymptotes on cosecant everywhere sine equaled 0. All right? But then the reciprocal of 1 is 1. So it's coming down and touching it right at pi over 2 where sine equaled 1. But then again we have the asymptotes everywhere sine equaled 0. Because the reciprocal of 0 is undefined. Okay? So you have these little, what look kind of like parabolas, even though they're not, but those little U shapes between all the asymptotes. Okay? So, kind of neat graphs to look at, and so that's kind of interesting.